So here, Fourier integral of a function f defined in the interval in the negative infinity to positive infinity is given by this formula number 4. Fourier integral, remember here, this is not Fourier series. This Fourier integral representation of a function. If in Fourier series, we will represent the function as a series of cosine and sine functions, isn't it? The condition for Fourier series is the function should be periodic and piecewise continuous and lot of other conditions, isn't it? Here, the Fourier integral, the function is not necessarily to be periodic. It should be defined from negative infinity to positive infinity. That's all. So we are going to start with this formula. This is the formula. Here we need to see this integration is integration with respect to a new variable alpha, not x. Integration from 0 to positive infinity, 1 over 5. And there are two terms, a alpha, b alpha, along with the cosine alpha x, sine alpha x. Almost things are looking like summation an, cosine, summation an, cosine pi x over l, isn't it? Plus summation bn sine n pi x over l, looking like this one, but instead of summation we have integration. Okay, a and bn has been replaced by a alpha and b alpha, and of course just like Fourier series we'll find a alpha here, b alpha here. So the formula for a alpha to find, if you find a alpha and b of alpha and substitute in equation number 4, you are done. You don't need to integrate this formula, problem number 4. You have to express a given function by using this integration. That's all. Just like our Fourier series for periodic functions. This is non-periodic function, right? Okay, here finding a of alpha is again integration with respect to x. In the original equation, it was with respect to alpha, isn't it? Here, integration finding a alpha, you have the function f of x function, and you take the kernel cosine alpha x, integrate this one, then the output becomes a function of alpha. There won't be any x. Integration of x, integration with respect to x, then substitute the limits of x, then you will find no x, only alpha will be there. So this will be called a function of alpha. Similarly, b of alpha. Do the integration of the same function with respect to sine alpha x. Here there is no constant term, and the limit is from negative infinity throughout this region, right? So when you integrate a alpha and b, when you find a alpha and b alpha, substitute in equation number 4, then you are done. The same concept of Fourier even integral, odd integral are possible. If you assume that f is odd function, if f is odd, what happens? This is odd, isn't it? An odd multiplied by even becomes what is? Odd function multiplied by even function, it will be again odd function. So integration of an odd function from symmetric interval negative infinity to positive infinity will be 0. You will find only b of alpha. If f is even, this will be 0 and you will find only a of alpha. So this possibly applicable here as well. And now that's what given here. Convergence of Fourier integral. Sufficient conditions under which a Fourier integral converges to f of x are similar to but slightly more restricted than the conditions for Fourier series. What is it here? In Fourier series we have seen if the function is discontinuous at some point, then how to find its convergence. If the function is discontinuous at x, then x, right limit at x and left limit at x, find the average, divide by 2, isn't it? And the conditions, when you read, there will be slightly some difference. Here f and its derivative must be piecewise continuous on every interval, and let f be absolutely integrable in the interval. Then the Fourier integral of f on the interval converges to f of x at a point of continuity. At a point of discontinuity, the Fourier integral will converge to this average. So this is all about the point of discontinuity. For point of continuity, it always converges. It doesn't matter what case it is. Okay. This is for Fourier cosine and sine integrals we have discussed. So for cosine integral, b of alpha will be 0. So second part from the first integral will be 0. And then this integration will be written from 2 by because this will be 2 times 0 to 2 by pi. Here in this formula there is no 2, it's 1 over pi. But when it becomes a Fourier sine or cosine, it will be 2 over pi. From 0 to infinity, A alpha for Fourier cosine integral, B alpha for Fourier sine integral. That's it. So you have to practice these kind of problems as well. Let's go to the first example. Find the Fourier integral representation of the given function. Write the formula. F of x is equal to 1 over pi integral 0 to positive infinity A alpha cosine alpha x plus B alpha sine alpha x d alpha. Isn't it? Okay. And all these terms are under bracket up to sine alpha x. Now, this is neither even nor odd function, isn't it? But defined from negative infinity to positive infinity. F is, see, there are 4 intervals you can see here. On the real line, you can say this is negative infinity and this end is positive infinity. Middle point is 0. See, negative 1. There is a negative 1. Less than negative 1, the function is 0. Between negative 1 and 0, the function is negative 1. Between 0 and 1, the function value is 2. And beyond 2, between 2 and infinity, the answer is 0. So the function is defined between only 2 points. Other points, the between 2 interval. See, here and here, the first and last interval, the function is 0. So when we find a of alpha, the formula should be from negative infinity to positive infinity f of x cosine alpha x dx. Isn't it? But we don't want to start from negative infinity. We can start from negative. On other parts it's 0, isn't it? So we can start this one as negative 1 to 0. What is the function in this interval? It's negative 1. Cosine alpha x dx plus another interval 0 to 1. In this interval function is 2. So cosine alpha x dx. So when you derive this first term, what do you get? Negative is outside. When you derive cosine alpha, it will be sine alpha x over alpha from negative 1 to 0. Second term is 2 times again sine alpha x from 0 to 1. So substitute the upper limit. Sine 0 will be 0. Sine negative alpha, sine negative x is negative, and the sine negative alpha will be negative sine alpha. So it will be sine alpha over alpha. The second part it is sine. Second part it will be 2 times. And there will be alpha in the denominator as well. Sine alpha x is 1. Sine alpha divided by alpha minus 0. This one should be carefully addressed. minus 1 to 0. And sine is 0, okay, this will be positive, and then outside there is a negative, because sine 0 will give you 0. Minus sine alpha, again there is a minus outside, there is a minus inside, so it will be positive inside and negative outside. Totally it will be negative sine alpha. You want to check it this, okay? 0. So sine alpha over alpha, the second term. So totally this, when you take sine alpha over alpha as a common term, it will give you minus 1 plus 2. So the answer is sine alpha over alpha. This is a of alpha, isn't it? So we just erase this part and find b of alpha. Erase this part. So the answer for a of alpha is sine alpha over alpha. Find b of alpha, which is again from negative 1 to 0 minus 1 times sine alpha x. No, it's not cosine, isn't it? Dx plus the next interval is 0 to 1, 2 times sine alpha x dx. Okay, so which is equal to minus outside. When you integrate sine, it will be minus cosine alpha x over alpha from minus 1 to 0 plus 2 times minus. When you integrate sine, it will be cosine negative, minus equals to cosine alpha x over alpha from 0 to 1. So simplify, substitute the 0 and negative 1, you get the answer as 3 times 1 minus cosine alpha divided by alpha. This is your b of alpha, isn't it? Now we have to use this a of alpha and b of alpha in equation number 1. This is our equation number 1. That will be the end of this problem. F of x is equal to 1 over pi from 0 to infinity a of alpha. A of alpha is sine alpha over alpha cosine alpha x plus b of alpha 3 times 1 minus cosine alpha divided by alpha times sine alpha x d alpha. That's all. We can simplify the term inside the integration if possible. Sine alpha. See, 1 by alpha is common, but it cannot come out of the integration because integration is with respect to alpha. The integration variable is alpha, so it's not a constant. So alpha should stay inside the integration. So 1 by alpha can be taken common, and then you can try to simplify further. Otherwise, you can stop here. Okay, that's it. We put upon the case. Now let's go for the next problem. The answer is given here. Next problem is quite simple. The function is just a constant function, only one part of the integration, isn't it? Problem number 5. Problem number 5. 2. Okay, problem number 2 from the textbook. As usual, you should find a of alpha. Therefore, the integration is from only in this interval 0 to pi to 2 pi 4 times cosine alpha x dx. So when you integrate it 4 times sine alpha x over alpha from pi to 2 pi. So simplify it 4 times 4 over alpha. Substitute x as 2 pi sine 2 pi alpha. As far as we don't know the value of alpha, we cannot write it 0 or non-zero, right? Leave it as. And sine pi alpha. This is A of alpha. And B of alpha will be from pi to 2 pi integration. Function is 4. Now the term kernel is sine alpha x dx. So integration of sine will get you negative cosine. This is negative 4 cosine alpha x over alpha from pi to 2 pi. So negative 4 alpha. When you substitute cosine 2 pi, you will get cosine x will be 2 pi. 2 pi alpha minus cosine pi alpha. If you don't want this negative outside, bring the negative inside and switch these terms. That is b of pi alpha, then the function f of x. 1 over pi from negative infinity to positive. So 0 to positive infinity here. A alpha 4 over alpha times sine 2 pi alpha minus sine pi alpha times cosine alpha x. Second term is in negative. So negative 4 over alpha cosine 2 pi alpha minus cosine pi alpha times sine alpha x. Close this bracket and then write d alpha. Further, you can try to simplify these terms by using cosine a plus b, sine a plus b, sine a minus b, sine a minus any of these formulas. That's the end of this problem. Okay. One more problem we will discuss and then we'll close this chapter. For this function, we'll find a of alpha. The formula is from okay, it should have been written from negative infinity to positive infinity, but the function is valid only between 0 to infinity. Other part it will be 0. So other part from negative infinity to 0, you can consider 0. Now e raised to minus x cosine alpha x dx. Right. So to solve this one, we will take the easiest route. We remember Laplace transform of f of t is equal to from 0 to infinity e raised to minus st f of t dt, isn't it? If t is x, s is 1, what we get here? And f of t is equal to x is 1. Cosine alpha, what we get here? It will be Laplace of cosine alpha, isn't it? Which is equal to 0 to infinity. S is 1. So e raised to minus t is x, e raised to minus x. And f of t is cosine alpha dx. Now, does it look similar? These two? Okay. Now, what does the meaning? This is nothing but Laplace transform of cosine alpha. Isn't it? The variable is, instead of t, the variable is alpha. So it will be s over s square plus 1. The coefficient is 1. So this is the answer. Instead of s, we have the variable. We can write the answer as alpha here. Instead of s, we have 1. This is 1 here. S is 1 here. Sorry. Remember, s is 1. So this formula, we know Laplace of cosine t is nothing but a square over a square plus a square. A square is the coefficient of um, t, isn't it? So t is x and there is no t here. So this becomes, this will be cosine alpha x. Okay. Alpha x will be alpha t, isn't it? Alpha t. Therefore, you should get a square over a square plus alpha square. Isn't it clear? So what happens here is s is 1, so 1 over 1 plus alpha square. That is the a alpha. So in the similar way, you can try to find b of alpha. In the similar way, try to find b of alpha, which will be alpha over 1 plus alpha square. It will be Laplace of sine kt. We check it, isn't it? So we got both alpha, a of alpha and b of alpha. So substitute in the given function, you will end up with the answer. So what is a of alpha? A of alpha is 1 over 1 plus alpha square, and b of alpha is alpha over 1 plus alpha square. When you substitute this in the function, f of x will be 1 over pi from 0 to infinity, 1 over 1 plus alpha square times cosine alpha x plus alpha over 1 plus alpha square times sine alpha x of this one d alpha. That's the end of this problem. That's the end of this problem. So practice this kind of problems and for cosine and sine integral as well, even and odd function as well. Thank you very much. That concludes our syllabus. Okay.